I would love to start with what are your biggest, let's say, problems with people out there that don't understand certain things? Like, what are you most emotional about? What don't they get? What should they understand to do better in this world of AI and data science and machine learning? Is there anything that you would like to teach the world, basically, in a minute or two? Can we start with whoever wants to volunteer? Otherwise, Jerry?
Yeah, I can start. So at Facebook, I primarily work with kind of at the intersection of data infrastructure and machine learning. And what I observe to be very interesting behavior is when you talk to people who's very familiar with data infrastructure, they kind of think in their world. So a great example is, hey, why don't we just use Spark for all of your machine learning workload, right? All your sync HDD and all of that stuff, why can't we run in Spark? It already got all the stuff you need. It's not quite true, right? But that's kind of one kind of behavior I noticed, that is that you have these different bubbles of domain expertise, right? And when they cross, right, they rarely go completely over, right? Because of kind of how you view the world. And I do wish that there's a great way to cross the boundary, right? Because there's some real fundamental challenges with machine learning, and we covered quite a bit of that yesterday with respect to, for example, abstraction of data access, right? That's I mean, at least internally in Facebook, that's a huge problem. There's so many different data sources and data types, right? It far exceeds the structured data that data infrastructure is used to dealing with. How do we have the right abstraction for that data, access it, and make machine learning workload productive? Right? That's just like my 2 cents.
So maybe I'll echo the last thing you said. I think the world of machine learning sort of assumes few schemas with billions and billions of instances, but I'm increasingly interested in the problem of maybe there's still billions and billions of instances, but there's lots and lots and lots of schemas, and it's not clear we have much of a approach for how to deal with that, despite it being kind of a grand challenge, at least in the database community for a while. So when it's a big soup of messy data, you don't have this nice clean sparse matrix that is always kind of listed as assumed to be the input of the machine learning task. So image recognition and so forth is a huge set of images that works well, but if it's just a bunch of open data, open government data or something, there's something else. The other thing I'll mention, which is maybe sad, but the database community made a pretty big bet on shared nothing, low omdal numbers a long time ago. It seems to me the pendulum's kind of swinging back the other way, right? So the reinforcement learning examples that we saw and so forth, this is a fairly small problem specification, and then enormous amounts of compute to sort of get somewhere on it. So I guess I just leave that out there, that it may not be about sort of shoveling petabytes around going forward. I think Mike Jordan once, in a very brief abstract for a talk he was giving at University of Washington, said something sort of obvious, but it sort of hit me, was, if you have an entire community that's trying to figure out how to design new algorithms to tame massive data sets, and you have another entire community that's trying to extract signal out of very small data sets, namely statistics, something seems in tension here. And so anyway, I wonder if recognize that it may not be about shuffling around petabytes.
Yeah, just building on the data part, I guess. The basic idea from new people to ML, and these are even people who really understand technology in general, is just the idea of garbage in, garbage out. That if the data isn't clean enough, whatever you get is probably not going to be good, and that still remains a problem. Whatever you do, you still see people making that mistake over and over and over again. As somebody who sort of pushes on making tools for ML and really making that more accessible, I think it's probably going to be more important to keep pushing on that, where people can't shoot themselves in the foot that easily, right? You really package things up in the right way so people mostly get things as much as possible. I don't think there's a panacea yet, but I think we are headed in the right direction in terms of improving things, cutting down what users have to think about and not think about. And you're right, in terms of the open databases, I don't think we've done enough work. I think there's still a pretty open problem there. But that's sort of the big area I think is really something we need to push on.
What about the validation schemes? That's one of the things I see a lot, that people just throw in a data set and say, I'll do an 80-20 split and let's see what happens, right? And then they train for 5 days, do all kinds of tuning, and then they say, okay, now it's good on my 20% that I held out. But they forgot that the whole thing was a time series and you can't do a random 80-20. Or maybe it's something that was, had groups in it and you mixed up people from different groups into train and test, and then you cheated by seeing them already in the training, which you shouldn't have seen, and so on. So what do you see about validation schemes in general? Do people do those right in your companies where you work, or is that also a concern?
Start with me.
Because that's something that's hard to specify, right? You have to, you can just say for this data set, you do this scheme only and nothing else, because it might change, or so you have to have this domain insight.
Maybe I'll deflect the question, and then they can answer more intelligently to your actual question. So one thing I'll mention about validation that is increasingly important is the recognition of biases in your data set that pertain to the actual problem you're trying to solve, but may not show up in any sort of typical mechanical evaluation scheme. And so there's a lot of, there's a conference that I'm on the steering committee for called, it was called FAT-ML, Fairness, Accountability, and Transparency in Machine Learning, and now it's called FAT-STAR, in an attempt to generalize to the database community and so on. And this had sort of piddling number of papers around this stuff, and it jumped to, oversubscribed by 500 seats last year. And so people are increasingly aware of this, but the image recognition data sets, for example, that are, or facial recognition data sets, when you have nothing but white people in them, you're going to have real problems in the application you deploy that's trained on those data sets. And so somehow you need to be able to track that through that. So it's not just about the mechanism by which you validate the models, but the overall problem you're trying to solve, and understand all the way back to the source what sort of biases you're propagating. And you get autonomous vehicles that are killing people in the streets because of it, so it's a pretty big deal.
So, my answer is going to be short. Yeah, we don't do that very well. Yeah, it's definitely an area to invest in.
Yeah, it's similar. People do make those mistakes all the time, I guess. I think it is getting better, though. At least at Google, we've seen, as we've given more examples, as we've seen more applications and developers sort of pick up these different things, and they see how it's done, so that helps A. B, going back to the tools, we have more tools around just model analysis. Instead of just saying, okay, here's the final accuracy, can I actually slice it, dice it across different axes to see how it's doing across these different things? And often those point to problems very easily. Again, that's still, their tools are there, but the process is still fairly manual. People have to figure out what they want to slice it by. There's some automation. I think we need more of that. I think we need to catch, again, things like, okay, I've seen this data, so my accuracy or whatever metric I'm doing is going to be perfect. That's probably a sign of a problem, right? Especially early on in your cycle. So catching those things and building better tools is still important. I don't think it's a done deal anyway.
There's a question from the audience.
It's a bit horrifying to hear Google and Facebook say that you make those mistakes all the time, because now flip to the other side in the utility with one data scientist who's fresh out and didn't go to Stanford to get their degree. And they're just going to throw these tools, they're going to throw a bunch of data at an algorithm, and they're going to think they've got a model. I think this is a huge problem for our community, and I think that it's going to create a really, really, really deep trough of disillusionment around the tools and the results.
Yeah, I absolutely agree. And I think that's why building the right tools which take away a lot of the typical problems, or try and handle that, or at least find those for you, are going to be really, really important for us to scale to this long tail of people who want to do this kind of thing.
What advice would you give yourself 5 years ago or 10 years ago, if you could?
I'll say, so about 7 years ago, I got into this field, and I would go back and say, you made a great decision. So it's definitely changed a lot over the last 5 years, right? We made a number of bets. A lot of them have panned out well. Again, not to say that everything we did was right, but in that sense, things have been great. Looking ahead 5 years, could I do the same? we'll see. We'll find out in 5 years. But so far, things seem to be going well.
So I actually got into this field relatively new. My background is mostly in the data part. Right? Machine learning is new to me within the last year. So I guess 5 years ago, I would have told myself to look at machine learning. What's interesting, though, I think in the last few years, the developments in this space, the speed at which is happening across many kind of different companies and whatnot, has really accelerated, and it's very exciting to see that and to be in this space, and especially really exciting to be able to leverage the background in data processing, data storage in machine learning.
I'm not sure I have anything to add. I'll publish more, I guess.
So what do you see this world going into in like 10 years from now? Is there going to be a singularity and we won't see any of it? Or is it going to be the same as today, just more disillusionment and people struggling with understanding what these exabytes mean?
I mean, I guess one thing I think is that as it's gotten easier and easier and easier to do the kinds of stuff, the kinds of engineering technical work that was hard, right? So it was really, really hard to deal with a terabyte at some point, and then it became a lot easier, and now maybe that's not so bad. It was really, really hard to set up deep, multi-layer networks and so forth, and now that's quite easy, and you can do all kinds of fancy stuff. So you can sort of think about what happens with the limit there, where it's really not hard to do anything you dream up. If you've got some input data, and you've got kind of a task in mind, you can kind of express that as a problem and it'll learn it up. Well, I'm still worried about this bias thing that I was talking about, right? I don't know how to solve that with making things easier and easier and easier. In fact, it almost gets worse with that effect because now you sort of amplify and propagate these sort of biases and get them out there in the world even easier, and then you realize, oh gosh, we screwed up. So I'm increasingly interested in that. And there are some technical interpretations of the problem. That's not just a human in the loop kind of thing. It's a how do we change our objective functions to incorporate notions of fairness or distance from the distance from the training data or something to kind of optimize for those kind of concerns. So anyway.
So yeah, I don't really think singularity is happening anytime soon, so I'm not worried about that piece. I do think that a number of things that we're doing now and that have become better over the last few years will probably automate more. So we've been pushing on this whole idea of AutoML, where you can, for standard kinds of problems at least, you can automate a large chunk of it, right? You have the data set and you train it. So I think the things that we are good at today for like the very specific vertical solutions, I think we'll just do very, very easily. In the next few years, I hope that we'll push more on the slightly more general solutions where we can solve bigger problems. There's this whole push on assistants, which clearly need to understand not just one specific problem, but do lots of things to be useful, be more useful. I mean, they are useful today, but be a lot better. I think we'll see a lot more things that interact with us. So, whether it's tiny robots around the house or things like that. And so in some ways, and I don't think these problems, like the underlying technology is still going to be there. I think the problems we work on will probably shift. I don't expect to be working on exactly the same problems that we're doing now, hopefully. So.
10 years from now? So I can't make predictions, but I feel like the problems that we have, right, and is a lot of, I think can't be held to a large degree with the it seems like the commitment from various places to open source all the technology that's being built in the AI space, right? And to make the technology available to use for anyone, so that so you can actually scale up the investment, right, in this space, and hopefully reach to somewhere higher level. Right now, I think the tools are still pretty fragmented and disparate, but hopefully over time, more and more higher level functionalities get built and open sourced, and then for everyone to use.
Yes, that's for the tools. And what about the data? If everybody keeps their data for themselves, isn't that the new gold? Is that going to be a problem that some companies sit on pretty much all the data and the rest can just watch? Is that a concern, or should they just
I mean, and I think
forced by the regulator somehow, and then that becomes a mess?
Two things. One is everybody's personal data, and that's probably what you're asking about. We can talk about. But there's another trend I think you sort of see is that the total number of data sets in the world is actually not that big, I claim. There's the set of all videos in the world, and Google has that pretty much wrapped up. There's the set of all documents in the world, and everybody's got that. Facebook sort of has all your data in the world, and a few other people do too. So in some sense, it changes what we need for delivering technology, right? Because there's only, it becomes feasible to sort of design a specialized system that's just for video or images or something, because there's only going to be one deployment of that. You're not going to necessarily have this little balkanized thing where everybody's trying to do their own thing. It's a bit of a caricature. It's not quite this extreme. And then specifically, so I do think there's some, sort of to your point, I do think there's some concentration of data in fewer and fewer places, and then you can take different, you don't have to be quite as general about how you attack those problems. And then with personal data, yeah, I don't know. Well, maybe I'll let them speak and we can talk about that.
I would say two things. One, on data itself, I think the amount of data being produced every day keeps increasing. So, if you look back at 5 years ago, what the data was, that's tiny compared to what we have today. I think that same trend is going to continue. So it may not matter who has current data or whatever, right? And then two, in terms of algorithms and stuff, we're also starting to see more and more work where you don't need as much labeled data, or you don't need as much data that you already have. You can either generate it, you can generate interesting data that looks similar, and so on, for lots of different areas. And I think that will just allow us to not rely on tons of data that you have to collect, and really allow lots of people to do this.
So, data and Facebook, that's kind of a hard question to answer. And so from inside out, I'm pretty certain that Facebook is 100% committed to protecting user data privacy. And so with respect to sharing that, there's nothing I can comment on. So yeah.
What about reinforcement learning? A lot of people are looking into it and saying, oh, it's cool, I can learn video games and all that, but is it going to be practical? Is the average Fortune 500 company going to rely on reinforcement learning methods to operate better, or is that just for certain applications like self-driving cars?
I think right now it's way too hard for most people. Even at big companies, companies like Google and so on, it's not when people get started, and these are good researchers, it takes them a little bit to really make that work. It's sort of like where deep learning was maybe 6, 7, 8 years ago, where you needed to really understand things to make it work. And I think unless reinforcement learning sort of jumps over that and gets to be where it mostly works, I think it's going to be a while before it gets into these.
Yeah, Facebook is in a similar situation with respect to reinforcement learning.
I have a question regarding LSTMs. Read the other day that attention is everything, CNNs is all you need. Is that true? Or do we need recurrent neural nets?
So as someone less knowledgeable probably than my colleagues here about this stuff, one observation that we made way too late just recently, just as an anecdote, was the fact that LSTMs, really only pay, without attentional models in there, they only pay attention to sort of the last little bit of the sequence. And so we had this really striking results in sort of training models on big workloads of SQL queries and doing all kinds of amazing things with them. And then we realized that essentially what it was learning was the last 6 tokens in all these long sort of 1,000 tokens queries, and it was still good enough to do the classification on it. But the fact that, and the other people had already made this observation, we should have clued in sooner and so forth. But that those kinds of experiences, I think, sometimes make you realize that we don't know as much as we think we do. And then as far as whether attention models are going to solve all this, I'm not sure, but it seems promising.
Yeah, Facebook does use or starting to use LSTM internally, and that's kind of one interesting thing with LSTM is it appears to be much easier to implement and experiment with in an eager model like PyTorch or TensorFlow eager than the graph-based model that Cafe2 or the Arno TensorFlow has.
I think it's TBD, really. It's not decided yet. There's definitely interesting results with attention, and you're right about LSTM's not quite covering the long sequences and so on. My guess is in lots of these areas, we're still seeing lots of iterations. Probably people will combine these ideas. Maybe we'll need sequences. And there are some people who say basic ideas of these recurrent nets is something that the brain does. Again, we're very loosely inspired by the brain. So maybe there are some ideas that still stay around. Attention is clearly very powerful, and it's allowing us to do lots of new interesting things. So I expect more research in that area too.
Thank you. There's another question from the audience.
Two related questions. One is beyond recommendations and other stuff in Google and Facebook, how much you're using these ML techniques for operational systems, health monitoring, and so on, for the production systems. Related to that is when you put any of these models in the loop, a standard debugging, we know how to sort of do debugging of software. In these models, how well developed you believe the practice of debugging technology is when a model is in a closed loop?
So in terms of where all it's being used, actually Google does use it in lots of different places and all kinds of products in the data center also to some extent. Can't talk about exactly where, but there's definitely lots of push in pretty much across the board. And then the second question in terms of debugging, I think it's mixed. So there are some areas and there are some techniques over the last year or two that people have developed in terms of identifying, okay, here's a problem, or here was a prediction, where did that come from, and just understanding the model or what's happening there. And there's a fair bit of progress that's happened there. Still, if you compare to just your standard programming where you know exactly what the results are, and it's very, it's not as easy as that, and it's going to be a while before it gets there, I think.
Yeah, Facebook does use machine learning outside of those things in data centers, right, as well. And as far as debugging models, yeah, it's really hard. And there's tools that that we have. They're not as easy as setting a breakpoint and seeing stack traces.
To the previous question about different models being good at different things and having weaknesses and such, there's some efforts right now, a la Data Robot, throw every model at it and see what happens. I didn't hear you guys talking about using those kind of techniques at all. You very focused on very specific techniques for very specific problems. What do you think about the concept of just throw all the models at it and see what happens?
Maybe as somebody who's only recently coming into the machine learning space, my feeling is that either all the models find the signal or none of them do, roughly. And so the choice, whether you're going to choose, not all the models, all the basic algorithms. And so the automation of trying a bunch of algorithms and sweeping over parameters and so forth, it's an important step maybe in the pipeline for some problems, but I don't think that's really where the real challenges are. I think it's in sort of deeper understanding of the actual application you're trying to do and taking advantage of those requirements as opposed to try 3 different, or 10 different variants of essentially linear models and seeing what they learn. But that may be a little bit naive compared to what folks would say.
I think I'm also relatively new to machine learning, but I feel like the level of understanding of the various different algorithms, I don't think has reached a bottom yet, and it still requires someone with a long history of training in the specific domain to be able to be effectively applying these different models to achieve the desired outcome. So I think we're kind of far, in my opinion, from just trying a bunch of different models. They don't, a lot of times they don't even have the same kind of data input.
I think at Google we've seen that we have people using different kinds of models, so it's not just deep learning, but deep learning is definitely taken off in terms of being the most popular today and what people are using often. One of the things, and where this starts to differ for a lot of the linear models and so on that you do, you often have to create lots of features. So there's the feature engineering, and again, you can automate that too. We had systems that used to do that with logistic regression and so on, Candel and others that we published on. But often the regime that you are in with these versus a typical deep learning model is fairly different. So we often see people trying one set or the other. In deep learning itself, just in terms of architectures, hyperparameter tuning, all of that, people do that where they get the basic stuff there and then either just learn all the hyperparameters using automated tuners, or now, more recently, even starting to learn the architectures themselves. So there is an interest in automating as much of it's possible, but maybe slightly different ways than what Data Robot is doing.
I'm glad you asked. I can say we have a driverless AI now at H2O, by the way, that does just that. It's parameter tuning and feature engineering, all automated. So Grandmaster style, Kaggle master in a box on GPUs. It's not using deep learning as a main model yet. That's going to come next month, but it's using XGBoost and ensembles and all that. So it's very good for structured data. There was a question.
So to go back to the topic of data and all those things, in many other sciences, there's lots of oversight. So if you're doing research, you first have to get trained in the methods. If you want to do research with human subjects, you have to get approval from an IRB or something. If you want to commercialize something, you have to go to an agency like the FDA, USDA, things like that. My question is, with a powerful technology like machine learning and AI, what are some of the discussions going on within Google, Facebook, and other places? And what's sort of the sketch of what this kind of oversight might look like? Because I think that there needs to be some oversight. And also to the point made earlier, there might be some need for people to get some sort of training in evaluating their application before they can go deploy it in the real world. So I was wondering if there is serious discussion going on within all of your groups. And if so, if you could give us a summary.
I can talk about a couple of efforts where we push on these kind of things in terms of ethics, and there's this partnership on AI that we've joined with Microsoft, Facebook, and a few other companies, I think, to push on where should this area go in general and so on. That said, I would say the key premise that you're starting from is that AI itself needs to be regulated as AI or ML or whatever. I mean, it's a very loose term in some ways. Whereas in a lot of ways, it's still built on the foundations of computer science and mathematics. So is that really that different from anything that we've been doing in these disciplines already? And they're not regulated. Now, where it starts to get relevant in terms of regulation is when you start to apply it to areas like healthcare, which directly impacts humans and us. And clearly, if we build, for example, the healthcare example that I was talking about, if we start to deploy that somewhere, that should go through the appropriate process and regulation that is needed for that kind of application. On the other hand, if I'm making something just to recognize images that I run on my phone, I don't see what the point is for regulating that, and that's just slowing progress down.
I maybe so I don't disagree, but I do disagree a little, I guess. So I think that I worry about anything that draws a hard line between, here is the technologist whose job is to jack up accuracy as high as possible, and then it's somebody else's problem downstream to sort of worry about the regulation, how it's applied, and so forth. I think that's basically the model we've been under for a while, and we've sort of shown we're seeing now that it doesn't work that well. So the people who are developing the technology need to be involved in share accountability for what happens downstream with the technology. I do agree that obviously some things, you're running something on your phone, there shouldn't be some sort of weird, liability thing you have to sign just to use that. But I don't like throwing it over the fence sort of solutions. The other thing I'd point out is that GDPR is coming down the pipe, and now although that's mostly about privacy, there is plenty in there about algorithmic decision making as well. It's not clear. It doesn't seem to me to be the right direction necessarily, but it's going to be there whether we like it or not. So I think, yeah, you absolutely will see regulation in the space about when someone's affected by a decision made primarily by an automated system, there's rules about how you complain about that and how you sort of, who's accountable for changing that value and how you can see the source data and so forth. So we're definitely going to see that soon.
So on the Facebook side, I think much of this has been recently discussed, and there's congressional hearings and whatnot. I'd recommend you to actually look at a lot of stuff. So I'm not personally close to the policy stuff. So on the training side, training to be better at applying this technology. The company does have structure for that. There's classes and all that, but it doesn't seem like it's enough.